Creation and simulation of a high common mode voltage difference amplifier circuit using TINACloud. In this tutorial video, we will present how to create and simulate a high common mode voltage difference amplifier circuit using TINACloud. Here is the original circuit we want to recreate for demonstrating the use of TINACloud's schematic editor. Let's see how to create such a circuit using the SPICE model of the OPA 735 operational amplifier. Click the SPICE Macros tab on the Component toolbar. The toolbar of the SPICE macro components appears. Click the Operational Amplifiers icon. Click the little arrow in the Operational Amplifiers display window. Select Texas Instruments. You can now select the op-amp OPA 735 from the list, or enter the part number into the top left search field of the dialog. Select OPA 735, then press OK. The selected IC will appear attached to your cursor, and place it anywhere on the workspace. Next, place the resistors R1, R2, R3, R4, R5, R6. Position the symbol using the mouse, then left-click to place it. The R2, R3, R4, R5 should be rotated by 90 degrees. Rotate them by clicking first the selected item, then the rotate left or rotate right symbol. Next, add the current arrow AM1 and AM2 from the meters toolbar. AM1 and AM2 should be rotated by 90 degrees. Note, you can rotate parts even before you place them by clicking the rotate left or rotate right symbol. You still need to add a few more components. Go back to the basic toolbar and add the power supplies to the circuit. Next, select the current generator from the sources toolbar. Then add the grounds. Now you can wire up the circuit. Note that TINACloud has an advanced wiring tool that automatically inserts the components into the wire. Finally, select and place the voltage pin from the meters toolbar. Position a few component labels by clicking the label first, then holding down the left mouse button. After you place it, just click an empty spot on a workspace. You can move components along the wires or modify the wires themselves using the rubber line capability of the tool. So far, the components were inserted using their default values. Double-click the component and enter the required component value, then press OK. Double-click the resistor R1 and R2 and set their value to 20K. Enter 1.98 M for R3 and R4 and 4.02 K for R5. You can also rename the component label. Change the resistor R6's label into R shunt and enter 1 ohm in the resistance field. Next, change IG1's label into iLoad and enter the value 5 in the DC level field. Set the signal of the current generator from unit step to square wave. Then set the parameters as it is shown in the signal editor window. We would like iLoad current generator to appear first in the diagram window, so add :1 in the component label after the name iLoad. Set I/O state of AM1 and AM2 from output to none to avoid being displayed in the diagram. Set and rename the power supplies as it is shown. Now your circuit is ready. Save it, then test it. Note that the program automatically saves the changes into this file while we are editing. Save your circuit under the name High Common Mode Voltage Difference Amplifier. To start the simulation, select Analysis, AC Analysis, AC Transfer Characteristic, calculate the transient response, run Analysis Transient. Here is how you can edit the scale on the axes. Let's add this diagram and a title to the schematic design using the schematic editor. Select Insert Diagram from the Insert menu with a green plus sign. You can also resize the diagram if you wish. Click the Insert button. The diagram will appear attached to your cursor. Position it, and then you can add it to the circuit diagram by pressing the left button of the mouse. Pan the circuit by holding down the left mouse button while moving the mouse. Add the title by using the Insert Text T icon. Edit text properties by clicking the Properties button. When you finish editing, press OK. The circuit with the embedded diagram appears. This concludes our High Common Mode Voltage Difference Amplifier circuit simulation video. For more information, visit our website at TINACloud.com. Visit our YouTube channel, youtube.com/user/TINA Design Suite.